Okay, class. Can you see my screen? Can you see my screen or not?
Boleh, Doktor.
Okay, class, where we stopped last 2 weeks? I think we have done for this slide. His bridge. Okay, class, never mind. Let me have a quick review or revise on this chapter. Actually, this slide contain of chapter 5 and 6, chapter 5 for DC bridge and chapter 6 for AC bridge. Okay, so Maxwell is okay. AC bridge has for construction Maxwell, Hayes, Schering, and Wien bridge. All construction or these 4 types of bridge actually have the same principle. Okay, in this chapter we will derive for unknown parameters. Sorry. Okay, so you can click for the audio for each slide. Okay, if you click this icon, so you can listen to the audio or pre-recorded audio. Okay, so each bridge will apply the same principle where we derive for unknown parameters. Okay, we derive for Rs or Lx or Cx. Okay, so you no need to remember or memorize the construction of each bridge. Okay, sometimes we will ask other construction. Okay, except these 4 bridges. Okay, we can ask other construction, not only for these 4 bridges. Okay, so no need to memorize the construction. Okay, what you should know is how to derive for unknown parameters Rs, Ls, and Cx. Okay, so these are the steps in AC bridge. Okay, we have done for Maxwell. Okay, actually, if you look at the final formula, okay, it is the derivation from the beginning. Okay, we derive for Rx. Okay, for Maxwell bridge, we derive for Rx and Lx. Okay, we derive for Rs and Ls. Okay, so finally we get this formula. Rx is equal to this R2 R3 over R1 and Lx is equal to C1 R2 and R3. Okay, even though finally we get the formula, we get the final formula for Maxwell bridge, okay, which is Rs and Lx, but actually we never use this formula to find Rs and Ls, meaning that in your final exam you should derive from the beginning. Okay, let's say the question find Rs and Ls from the figure of Maxwell bridge. Okay, from figure 1, let's say. Okay, so you cannot directly use this formula to find Rs and Ls. You must derive from the beginning. Okay, and after you get RS and LS, and then substitute the value of R2, R3, and so on. Okay, so if you just use the formula, then you will get only maybe 1 or 2 marks. Okay, but actually for this question, for AC bridge, the allocation mark for AC bridge is quite big. Okay, because you need to derive. Okay. So example 5.2 is just for using the formula. Okay, RS is equal to, okay, so Maxwell bridge is shown in figure 5.6. Okay, given the value of C1, R2, and so on. Okay, and then find, the question is to find the RS and LS, of course. So this example just use the final formula for RS and LS. Okay, but usually we should derive from the beginning. Okay, so this is for Hayes bridge. Class, can you hear my voice clearly, or ada is it echo? Because I buka kipas ni takut ada echo. Okay, tak clear tak?
It's okay here.
Okay.
Yeah.
Maklumlah work from home kan, ada kipas. Bunyi kipas. Okay, so any question you want to ask me? Okay, so actually all the construction, okay, for construction we just use the same steps, okay, the same step as in this slide, okay, from 1 until 6. Just use the same step, okay. Refer to the circuit and apply the same steps. Okay, so example 5.3, find the series equivalent inductance and resistance. Okay, this RS and LS, inductance and capacitance. Inductance and resistance. They can cause an opposite angle to null with the following, which meaning that null is equal to 0. This detector is equal to null, meaning that no current flow through this detector, meaning that the bridge is balanced. So we just use the balance condition Z1, Zx is equal to Z2, Z3. Okay, R2, R1, C1, and R3 are given. Okay, but this solution just use the formula, not deriving from the beginning. Okay, so usually we do not apply this method. We apply derivation. Okay. Okay. Schering bridge is used for precision measurement of capacitors. Okay. Because the unknown parameters for this bridge is RS and CX. Okay. C3 is a high quality microcapacitor for insulation measurement. So now we want to derive. How to start? We start with writing balance equation Z1 Zx, okay, is equal to Z2 Z3, okay, and then we take out Zx. Zx is equal to Z2 Z3 over Z1, okay, and then what's next? We define each Z, okay, Zx is equal to Cx series with Rx, so Rx plus, okay, 1 over j omega Cx. Okay, you can leave your equation like this, no need to convert into Rx minus j over omega Cx. Okay, and then Z2 is equal to R2. Okay, so this is parallel circuit, so we need to Right, like this, 1 over Z1 is equal to 1 over R1 plus 1 over ZC1. Okay, so 1 over R1 plus, after we make it inverse, so plus J omega C1. Okay, any question up to here? Any question? Akif, any question?
No, doctor. Okay.
Okay. Okay, next, what else? Z3. Z3 is equal to the impedance of C3 only. So 1 over J omega C, this is C3, okay? C3. Later, I will upload the latest version of this note. Okay, so you just leave your Z3 as this. Okay, no need to convert it to minus J over omega C3. Okay, I did like this because I want to make it same as the node. Okay, okay, and then we substitute all Z's into the balance equation. Zx is equal to Z2 Z3 over Z1. Okay, so Zx is equal to this. Okay, Zx is equal to Rs minus J over omega Cx equal to Z2. Z2 is equal to R2, right? Okay, R2, and then multiply with Z3. Z3 is equal to this minus J over omega C3, and then divided with Z1. Z1 is equal to this. Okay, 1 over R1 plus J omega C1. This is 1 over Z1. Okay, so we just multiply with this. Okay, and then what's next? So we expand this equation. Okay, okay, we multiply this and then okay, like this. After that, we equate the real and imaginary terms. Okay, we equate. So Rs is equal to, okay, this is a real term, this is real term, this is imaginary term because we have J, and this is imaginary term. So we equate this real with this real term. So Rs will be equal to R2 C1 over C3. Okay, and then this is imaginary part, so minus J over omega Cs is equal to this negative JR2 over R1 omega C3, and then we simplify until we get Cx. Okay, so please check your final formula. Please make sure that there is no unknown term in your final equation. Okay, so in Rx, no unknown term. Okay, meaning that no Rs, no Cs, or no Ls. In Cx, we have done for Cx because there is because no more unknown term in Cs. Okay, no Rs, no Ls, and no Cs here. Any question? Ramona, okay?
Okay, doctor.
Okay. Okay, and then this is dissipation factor. Okay, we can just use the formula you been asked in your final exam. Sharing bridge. I will go through all the bridge. After that, we discuss on tutorial and extra question. Okay, if you look at this solution, okay, an AC bridge has the following constant on AB. Okay, we have capacitor C1 parallel with 1K, resistor AD, resistors BC, we have capacitor, and CD we have RS series with CX, and frequency is given. Okay, determine the unknown capacitance and dissipation factor. The unknown capacitance is Cx. Okay, so this solution just use the final formula derived from the circuit, okay, that we have learned previously. But are we going to use this formula during your final exam? Rabia atau Adawiyah? Adakah dalam kelas ni Rabia atau Adawiyah?
Ada.
Okay, ni tengah bercakap ni Rabia atau Adawiyah kan?
Ya.
Okay, so are we going to use this formula in your exam?
Yes.
Yes, okay. We should derive from the beginning, okay? And finally we will get this, but you should derive from the beginning. What is Z1, Z2, Z3 and Zx? Follow all the steps until you get the Rs and Cs. Okay, this is a shortcut. You will get only 1 or 2 marks. Okay, the next is Wien's bridge, used for frequency measurement, also used for the measurement of an unknown capacitor with great accuracy. Okay, so in this construction, what are the unknown parameters? Capacitor, okay, capacitance. The impedance of one arm is, okay, so as usual we write balance equation, okay. So we define each Z. Z1 is equal to R1 plus 1 over J omega C1. Okay, it is equal to R1 minus J over omega C1. Or you just leave your equation here. R1 plus 1 over J omega C1, that's all. The admittance of the parallel arm is, okay, so this is parallel Z3, so R3 parallel with C3. So 1 over Z3 is equal to 1 over R3 plus 1 over C3 and equal to this, okay, and equal to this. Okay, and then using the balance equation, let's say Z2 is the unknown. Okay, let's say Z2 is the unknown parameter. Okay, so Z2 is equal to Z1, Z4 over Z3. Okay. So R2 is equal to, okay, so in this bridge we find frequency. Okay, in this bridge we find frequency. Okay, that's why the final formula is frequency as well as C3. Okay, measure unknown capacitance. Okay, so R2 is equal to, okay, so Z2 is equal to R2, Z1 is equal to this, Z4 is equal to R4, and Z3 is equal to this. Okay, so we substitute all Z with the equation. R2, okay, so this is Z2 is equal to R2, and then this is Z4, right? Okay, Z4 multiplied with Z1. This is Z4, and Z4 is equal to R4. Okay, and then multiply with Z1. Z1 is equal to this, R1 minus J over omega C1. Okay, so this is Z1, okay, and then what? Divided with Z3, Z3 is equal to this, so we just multiply with this, okay? This is component of 1 over Z3. Okay, and then please expand your equation, expand, and then please rearrange your equation so that real part here, and then this is imaginary parts. Okay, and then at this left hand side we have only real part, so we just R2 is equal to this, and then how about this is imaginary part. Okay, at left side we the imaginary part is equal to 0, so minus j, okay, all this term is equal to 0, okay. And then R2 over R4, okay, so and then you expand your equation, okay, until you get, okay, omega R2 over R4 is equal to, okay, okay, so we take, we put R4 here, okay, and then omega C3. Okay, so this is the imaginary part here. Okay, this is imaginary part. Okay, and then we get omega. Sorry, omega square is equal to this. Omega is equal to 1 over, okay, omega is equal, as omega is equal to 2 pi f. So we, f is equal to, C3 is equal to, okay, so we take out C3 from this equation. Okay, C3 is equal to R2, R4, sorry, R1, R3 minus R2, R4. Okay, if you look at this example, okay, so this is the formula for C3. Find the equivalent parallel resistance and capacitance that cause Wien bridge to null. Okay, all parameters R1, R2, R4 are given. Okay, omega is equal to this 2 pi f. So 2 pi multiplied with frequency 2.5 kilohertz equal to this. Okay, R3 is equal to okay, so find the equivalent parallel resistance. Okay, and capacitance, resistance and capacitance that cause to null. Okay, so actually C3, okay, so this is using the formula, but we will use the derivation. Okay, so from the conclusion, Maxwell and Hayes bridge find for unknown inductance, Schering and Wien's bridge find for unknown capacitance. Okay, Wien's bridge measure frequency as well. Okay. Okay, we are end of chapter 5. Now we go to tutorial. Okay, so okay, number 7. Okay, number 7 in your tutorial 5. A balanced AC bridge has the following constant: ZAB equal to R1 equal to 500, ZCD is equal to ZX, ZBC equal to R2, okay, and so on. And then a voltage of 10 volts and 1 kilohertz is applied to the bridge at points A and C. Sketch diagram and calculate the unknown constant ZX. Okay, so the first step is to draw, to sketch the diagram of this bridge. Okay, so ZAB, okay, so and then you draw A to B, we have R1, okay, put 500, and then CD, Okay, BC, B to C, we have R2, 1 kilo ohm. And then CD is ZX. And then in your question, it is YDC, I think YDC, right? Okay, but actually it is YDA. YDA, we have Y3, this is admittance, okay? Reciprocal of impedance is equal to J omega C. Okay, meaning that at DA we have only capacitor, okay? Y3 is equal to this. Okay, so after we sketch the diagram, okay, calculate the unknown constant Zx. Zx is here, so the first step is to, what is the first step? What is the first step? Class, what is the first step? What is the first step? Ahmad Izzat Imran. Izzat,
Ya, Doktor.
what is the first step? Use of
Cari
unknown
equivalent R.
equivalent?
R.
Equivalent R. Which one?
R1 darab dengan ZX sama dengan R2 darab Z3.
Okay, we call it as?
C3.
Okay, this equation is called as?
Oh,
Badru Amin, this equation is called as? Badru Amin? Balance
Ya,
equation.
Doktor.
This equation is called as? This equation is called as?
Balance equation.
Okay, balance equation. Okay, and then what? What is the next step? After we write balance equation?
Define all Z.
Yes, good. We find all Z. Okay. So Z1 is equal to Aiman Firdaus. Z1 is equal to? Aiman Firdaus. Aiman Firdaus ada tak? Aiman Firdaus. If you cannot speak, you can write. Aiman Firdaus. Akmal Luqman.
Z1 is equal to 500 ohm.
Okay, Z1 is equal to R1, it is equal to 500. And then Z2 is equal to?
Z2 is equal to 1 kilo ohm.
Okay, Z2 is equal to R2 is equal to 1 kilo ohm. Okay. Akmal Rakin, Z3 is equal to? Akmal Rakin, Z3 is equal to? Akmal Rakin, Z3 is equal to? Akmal Rakin mana? Arif Afifi, Z3 is equal to?
Z3 equal to C3.
So how to find Z3? Arif Afifi?
1 over J omega C3.
Okay, good. And then how about How about Zs is equal to, we substitute R2 Z3 over R1 into the equation. Okay. Okay, and then we get this. This is okay. So Zs equal to this. Okay. So any question, class? Okay, class, if you look at this number, so what is the component of Zx? Zahiri?
Yes, Doctor.
What is the component of Zx? Is it a resistor, capacitor, inductor, or combination of?
Resistor.
Apa dia?
Resistor.
Resistor. Okay. Anyone want to try? Izati Norina, if you look at this number, Zx equal to this, is it R, L, or C, or combination of? Izati Norina.
Combination of.
Yeah. How do you know? Agak aja. Anyone want to try?
Inductor.
Inductor kan? Inductor. How about others? Duhai? Duhai? If you look at this number, okay, so Zs is actually contain of R, L, or C, or combination. Duhai? Philip?
Yes, doctor.
So actually Zs is consists of R, or L, or C, or combination of?
There is R, there is L because of the J. Hold on.
Okay. Kamarina? Anyone want to try?
Yes, Doctor.
So Zs is actually consists of what? R, or L, or C, or combination of?
RL kot.
R.
RL kot.
Zx, okay, if you look at this number, this is the final answer for Zx. Okay, minus J1K. Okay, so from this number, we know that Zx is actually a resistor, or an inductor, or a capacitor, or combination of. Who want to try? Okay. The final answer is minus J. We have only imaginary parts, meaning that this arm has L or C, okay, but this is minus J. Minus J meaning that it is capacitor. Like Z3, okay, minus J. Z3 has, Z3 is equal to C3. It is a capacitor. If the final answer is positive J, so that arm has only inductor. Okay, if the final answer consists of real and imaginary term, meaning that arm has resistor and a capacitor or inductor. Okay, if J is positive, it is inductor. If J is negative, it is capacitor. Okay. Okay, so this is number 8 from your tutorial, an AC bridge in figure 6 is balanced, frequency 1 kilohertz, and has the following components. Z1 is your capacitance, okay, with C1 equal to this, Z2 here, your resistance R2 is equal to 500, Z3 resistance, okay, with R3 is equal to 300 ohm, series with capacitance of C3, okay, so Z3 is combination of R and C. ZS is RX series with either LS or CS, okay, so this is unknown. Find the value of Z1, Z2, Z3 in polar form and then obtain the value of RS and LS or CS. Okay, so previously this is complex number, okay, but this is imaginary term. Polar form meaning that you have to convert J to the apa ni, sudut. Apa sudut?
Angle.
Angle lah, okay, angle. Okay, so you should convert minus J minus or positive J, so you should convert J to angle by using calculator only. Okay, so how to solve this? Okay, firstly I put and this is combination of, okay, find the value of Z2, Z1, 2 and 3 and Zx. Okay, what is the first step, Ahmad dan Azim? Ahmad dan Azim?
Yes, Doctor.
What is the first step?
Define semua yang dia bagi.
Okay, define. So Z1 is equal to, we have only capacitor, the formula is 1 over J omega C, 1, okay, is equal to, you just write 1 over J omega is equal to 2 pi F, 2 pi, okay, F is equal to 1K, F is equal to 1K, and then multiply with C1 is equal to 0.2 microfarad. Okay. And we get minus J795.77. Please leave your answer for 3 decimal point. Okay. So 0.77 something. Okay. So this is polar form. Okay, this is polar form. Okay, find the value of Z1, Z2, Z3 in polar form. So this is Z1, this is imaginary term, convert it to polar form. Okay. Okay, class, now please try to calculate for Z1 until you get minus J this and until you get this polar form. Try it now. If you have any problem, just let me know now.
Doktor. Frekuensi punya value apa?
Apa?
Frekuensi punya value.
Frequency is equal to 1K.
Okay.
As stated in the question. Okay, try it now. If you get the answer of Z1, please type here. Yes. Okay, tadi Buana had answer just capacitor, right? Okay, so where's the question? The previous question. Okay, so we have minus J, meaning that we have only capacitor. Okay, now if you get the answer of Z1, okay, until you get the polar form, please type yes. You all kat hometown Semua khusyuk Okay, where is the first yes? Who will write the first yes? If you get the answer, please type yes. Anyone don't know how to key in your calculator?
Lupa.
Huh? Anyone don't know how to type on your calculator? Okay.
Me, doctor. I don't
Sorry?
know.
Don't know. Never seen before.
Never.
Okay. First, the first is to use mode complex. Okay. You please use mode complex in your calculator.
Okay.
Okay, and then you just type 1 over in the bracket. Okay, bagus Daniel. 1 over in the bracket 2 multiply with 2 pi multiply with 1k multiply with 0.2 micro I. Okay, you must press I. Or in your calculator, it is ENG button.
Okay.
ENG, okay. And then close the bracket. You will get minus 795i, right?
Yes.
Okay. Okay, and then please convert it to polar form. How to convert it to polar form? Press shift and then how to convert it to polar form? Class, how to convert it to polar form? I use the new calculator. I don't know how to transform it to polar form. Okay, it is my calculator is the white. Okay, the casing is white, so I don't know how to convert it to polar form. Okay, for the black one, okay, calculator the black one. I think you should press shift and then ENG button, right? And then equal sign. Shift plus shift and shift and then
Tekan shift lepas tu tambah.
and then equal.
Bukan. Shift lepas tu tekan nombor 2. Kalau yang putih lah.
I think that one for black casing, right?
Putih.
Class. I don't know. Okay. Anyone has problem to convert it to polar form? Do. Okay, kelas. Tadi siapa Apa pula ni? Anyone has problem? Okay, Al-Amin, Dan, Akil, Ahnaf, Badrul Amin, Kamarina, Philip, Nasrin, Arif, Bona, Izati, Daniel. Okay, how about others? Anyone still having a problem to convert from imaginary to polar form?
Yes, Doctor.
Omar, okay?
No. Shift
Still can-
and plus?
Did you get minus J?
Yes.
And then don't know how to convert it to polar form?
No, I don't know.
Try to press shift and then plus. Is it right?
Without complex mode,
It must be in complex mode.
it doesn't work.
Doesn't work.
Yeah.
Anyone want to help Omar? I don't know.
Okay, I will search on YouTube.
Good. Okay. So how about others? Hopefully you get the answer. Okay, and then Z2 is equal to 500 shift plus complex. Complex kat mana? Never mind, you should try, okay? And then Z3 is R series with C, okay? So Z3 is equal to R3 plus 1 over J omega C 3, okay? C3. C3, okay? C3 here. Okay, so 300. Okay, so now please try this. Make sure you get this. Ni panggil apa lah? Rectangular form. Okay, rectangular form and this polar form. Try it now. Try it now. Once you get the answer, start here. Yes. Please make sure all of you know how to get this polar form. Make sure you know how to convert from polar form to rectangular form. Ini betul ke I sebut ni rectangular form kan? Kelas?
Betul-betul.
Betul. I pun forgot because nama tak ni. Okay, so rectangular form and polar form. Make sure you know how to convert from rectangular form to polar form and vice versa. From polar form to rectangular form. Okay. Okay, good. Akil, Ahnaf, Daniel, Al-Amin. Okay. How about others? Please try it now. Okay, if we look at Z3 is R series with, okay, good Shazlina. R3 is Z3 is R3 series with C3. Okay, so this rectangular form, your answer must 300 is your real term. Okay, J is your imaginary term. Okay, for capacitor, your J will be minus J. Okay, so you must make sure that your answer reflect with your diagram. Okay, so if you get positive J, so you should check again. Okay, and then your polar, your angle will be minus, meaning that it is consists of capacitor. Kalau inductor, yes. If J is positive, then your equivalent Z3 must contain of inductor instead of capacitor. Okay. So minus J always refer to capacitor. Positive J always refer to inductor. Okay. Kamarina dan Arif Afifi, Alman Firdaus, Akil Ahnaf, Emma, Shazlina, Al-Amin, Daniel, Akil Ahnaf. Okay. And then now we substitute, we substitute all the Z to balance equation. Omar got the answer. Okay, good. So this is balance equation. Zx is equal to Z2 Z3 over Z1. So we substitute Z2 with 500. Okay. You may substitute with rectangular form or polar form. Okay, no problem. Okay, because your calculator will do the job. Okay, your calculator will calculate. You can mix polar form and imaginary form in your calculation. Z3 is equal to rectangular form or polar form. Never, no problem. And then Z1 is equal to, you can write minus J or you can write 795 with degree, with the angle of minus 90 degree. Okay, and then you just calculate by using your calculator. No need to transform imaginary polar form. Okay, finally you will get, okay, now please try this Zx. Make sure you get 1k plus j 188.41. Okay, now Zx. Okay, if you get the answer, start yes again. Find for Zx. Try it now. Good, Daniel. Okay, you must try it now. Sometimes you find that it is easy, okay, but you never try. When you try, maybe you can face with any problem. Good, Arif Afifi. Okay, so from this value 1k plus j188, okay, please guess what is the component of Zx. It is R, L, C, or combination of R. C, combination of R and L. Good, Bona. Okay. At the meantime, yeah, can be A. Okay, Philly got the answer. Akil Ahnaf, combination of R and C. R and L. Okay, let's vote for R and C or R and L. Akil Ahnaf said that R and C, Akmal R and L. How about others? R and L. Okay, so this is R and L. Okay, because positive J. Let's prove it. Okay, so Zx is equal to, okay, so we have found for Zx. Now we want to calculate for Ls. Actually, okay, so Ls is equal to, okay, so this is real term and imaginary term. Rs is equal to 1000 ohm. Okay, this is L. So Lx is equal to Zx is equal to J188.41. Okay. Okay, class. Are you okay? Is equal to J188.41. Okay, equal to J omega. omega L X. Okay, J omega L X. This is X. XL. Okay. Okay, class. Okay, so this is real term is Rx. This is Lx. Okay, so we call this term as XL. Okay, this is reactance. Okay, reactance of inductor. So it is J188.41 is equal to J omega Lx. So Lx is equal to 188.41 divided with omega. Omega is equal to 2 pi f. Okay, so we got the value of inductor. It is 30 millihenry. Any question? Any question? Can I understand? No question? Type no. Okay, good, NT. Okay, this is question. This is example taken from the textbook. In the measurement of capacitance using capacitance bridge comparison bridge R1. Okay, so the values are given for R1, R2, R4, C4. Okay, so from this information, the first step is to sketch the diagram. Okay, so BC, okay, we have R1 with the value 2000 ohm. Okay, and then CD, we have R2 with 2850 ohm. Okay, and then D2A, we have R4 series with C4. Okay, R4 series with C4. R4 is equal to 52 ohm and C4 is equal to 0.5 microfarad. Rx series with Cx. In branch AB, these are the unknown parameters. Frequency is given 400 Hz. Okay, no question here, but the question is to find the X. Okay, the question is to find the X. Okay, class, what is the first step? Z. What is the first step to solve this after you sketching the diagram? Azad? Azad?
Ya.
What is the first step?
Buat macam tadi cari satu-satu tu.
Pandai jawab. Okay. So okay, we write the balance equation. Zs is equal to Z1, Z4 over Z2. Okay. Or you can write like this: R1 Z4 over R2. Okay, because Z1 is equal to R1 only and Z2 is equal to R2 only. Okay. And then we substitute Z1 is 2K, Z4 is this, and Z2 is equal to R2, it is equal to 2850. Okay, so Z4 is combination of R4 and C4 in series connection. Okay, so 52 plus 1 over J omega C to C4. Okay, so now please calculate. Make sure you get this answer 36 minus J558. Try it now. Got the answer? Nak type apa pula? Yeah. Okay, please find for Zx. Make sure you get this answer. Try it now. Anyone don't know how to solve this, please? Macam mana nak tekan calculator? Nasrin, why? Oh, because it is.
Saya sampai
Because
sekarang tak tahu macam mana nak tekan calculator, doktor.
Alalalala, Nasrin, you use the white version or the black casing?
Calculator yang silver tu. Casing dia biru.
Casing biru kan?
Saya pakai yang tu,
Okay, Nasrin, the first step is to convert to use mode complex. Dah. Mana kalkulator lama I ni? Kelas, saya tak jumpa dah kalkulator ni. Okay, Nasrin, have you used mode complex? Okay, class, how about others? Have you got this answer? Zx is equal to 36 point blah 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 minus J. Okay, dah tekan mode complex. Okay, Arif got the answer. Good. Nasrin. Okay.
Ya, doktor.
Dah tekan mode complex. Dah tekan belum mode complex? Nasrin, are you okay? Okay, so how to solve this?
Tak dapat, doktor.
Dah tekan mode complex? You press mode menu. If you maybe you can try menu or mode. It depends on your calculator. Dah. By pressing. Huh?
Dekat saya bila saya tekan sampai kompleks tu dia tulis pole dalam kurungan 2. Lepas tu saya dah tak tahu nak tekan apa.
Pole dalam kurungan 2. Pole.
Ya.
Anyone can help Nasrin? Try to press 2. Maybe 2 represent complex.
Lepas tu nak tekan apa, doktor?
Okay, keluar tak? Ada tak keluar ke atas tu dia keluar apa I ataupun maybe CMP complex lah. Okay, now okay, ada tak button ENG? Ada kan?
Ada.
Okay, please press that.
Okay, dah.
Kan keluar I kan?
Betul.
And then you can calculate. Okay, let's try for, okay, do this first. Type 2 pi I, okay, 2 pi I, meaning that 2 pi and ENG button. and then multiply with 400 and multiply with 0.5 micro equal to what? Okay, and then please make it inverse. Okay, make it inverse and then plus with 52 and then multiply with 2k. After that, divide your answer with 2850 and equal to what? You will get this number. Philip
On the way,
dah.
Dr. On the way.
Okay, Philip, have you got the final answer for Zx? That is his point. This minus j.
We got for the 36.49, but the back part, the 558, I don't think I got it.
Okay. Okay, I think you using the black casing, right?
Yes.
Okay. If you use this white casing, the full term, okay, will appear, meaning that 36 and minus j will appear on the screen. But if you use the old version, I think you can press shift and then sign equals. I'm not sure.
Okay.
I forgot.
Got it. There is now.
Got the answer.
Yeah.
Okay. Okay. So Philip is done. So from this rectangular form, this is the real term, this is the imaginary term. Syntax error. Yeah, maybe please be careful. Be careful on each operation, okay? Akil. So type one by one. Okay, if you want to avoid error, you may write one by one. Okay, maybe Z4 first. Z4 is equal to 1 over J. 2 pi 400 multiplied with 0.5 micro. Okay, equal to what? Okay. Yes, it is the same. J in front or at the back is the same. Okay, it's the same. But make sure positive and negative. You should get negative J, okay? In your calculator, if you type, in your calculator, the J or I will be at the back, okay? But when we write, usually we put it in the front of the number, okay? But of course, you can also put J at the back, no problem, okay? Not a big deal. Okay, how about others? Got the answer? Please type yes so that I know that all of you got the answer. Okay, bagus Azad, Shazlina, Nasrin. Waiting for Nasrin. Bona, good. Alamin. Syawal. Muhammad Syawal. Saya masih mencuba. Ikhwan, yes, dapat syntax error. Nasrin should retry. Okay, maybe Shaz, apa tadi Nasrin Nasrin, try this term first. 2 pi, okay, ini pembawah ni. 2 pi I multiply 400 multiply 0.5 micro equal. Okay, dapat tak yang tu Nasrin?
Kejap Doktor. Dapat.
Dapat kan? Okay, and then we should make it inverse. Okay, so buatlah inverse. Kan? Make it
Okay.
inverse dapat?
Dapat.
Okay, and then
Dapat.
plus with 52.
Okay.
And then multiply with 2k.
Okay. Aduh.
And then divide with 2850.
Okay,
And then
dapat betul.
equal. Dapat dah ada final answer.
Dapat. Maksudnya
Alhamdulillah.
kena tekan tekan betul.
Satu-satu yang mana? If you type the whole thing, you might missing the bracket kan? Okay. So this is Rx. The imaginary term is for Cx. Okay. So because of minus J. So make sure you got minus J not plus J. Plus J represent inductor. Okay, and then now we want to find the value of Cx. Okay, we have found for Rx. So this is Xc. Okay, reactance. Okay, now we want to convert it to. You want to know the value of capacitance. So minus J558.438 is equal to 1 over J omega Cs. Omega is equal to 2 pi f Cs. Okay. So now calculate and then you will get 0.7125 micro. Got the answer for Cx? You got the answer? Type yes. You must familiarize with the calculation, your calculation with your calculator. Okay, using complex number. No need to think 1 over J is equal to minus J. You just use your calculator. No need to convert 1 over J is equal to minus J is equal to 1 over J. No need to do that. Good, Philip. Okay. Actually, this is the last. Apa pula akil miau ni? Actually, this is the last question. Okay, that we discussed today. We will continue other exercises on this Friday, inshallah. Okay. Actually, we are end of chapter 5 and 6, but we will continue doing exercise. Okay, we will continue on tutorial, and I will, inshallah, I will get other exercises from the textbook. Okay. Omar got the answer. Rabatun Adawiyah, Ikhwan, Winston, Atira, good. Shazlina, Hani, Nasrin, Bona, good. Akmal, good. Daniel, okay, good. Got it. Okay. Anyone didn't get the answer? You may type no. You may type no as well, meaning that you did not get the answer. Okay. We will try to help you. Al-Amin, good. Izzati Nurina, Badru Amin. Ada lagi? Empty, okay. I nak cari yang tak pernah menjawab ni. Ahmad Izzat, okay? Ahmad Izzat got the answer?
Dapat Doktor.
Okay. Aziz dapat kan? Aiman Firdaus? Fikri, good. Izzati. Duhair, got the answer? Duhair? Duhair, yes.
Dapat,
Okay.
dapat.
Siapa tu? Nasrin eh?
Saya dapat doktor.
Bagus, Alhamdulillah. Okay, Zaim Akil dapat? Zaim Akil dah kan? Okay, good. Okay. How about others? Winston dapat kan? I think Omar ada, Duhair ada. Okay, we have 39 students. Maybe the rest are on the way back to Malacca. Ya ke? CX formula apa? Okay, so this is okay, formula apa kan? Okay, what is the formula for this? Okay, so we know that XC is equal to 1 over J omega C, kan? Okay, from this. Okay, 1 over J omega. For capacitor, the impedance is equal to 1 over J omega C. For inductor, J omega L. For resistor is equal to R. Okay. So 1 over J omega C is equal to this term. Okay. Don't forget to put minus J. Minus J here is equal to this. Actually 1 over J is equal to minus J. Okay tak Daniel? Okay tak Daniel? Oh, okay. So you may continue your tutorial. Your tutorial 5 kan? Okay, you may continue. Okay, we stop at tutorial number 8. Number 8 kan? Okay, and you may continue to number 9. Okay. Please do it yourself. Okay. Inshallah we will discuss on this Friday, but you should try it first. Number 9. Okay. Draw and label the secondary and then determine the unknown impedance RSCS. Okay, so this is the as we have learned today. Okay, so the first step is to sketch the diagram of this bridge. Okay, and then follow the right steps. Okay, so you should try number 9, number 10. Okay, just derive. Number 11. Okay, please try it before we discuss on this Friday. Number 9, 10 and 11. Okay? Boleh? Boleh tak? Tak boleh?
Boleh doktor, boleh.
Okay. Anyway, that's all for today. Attendance list. Actually, the attendance list will be down. Apa ni? Will be in MS Team. Okay. After I click end here, stop recording.